Back. So today we shall be looking at the chapter 1 and we'll walk through some codes on TensorFlow 2.0 and we'll be using Google Colab because that is very easy. So what do we want to do today? Let's see how we can work with TensorFlow. So here I'm on Google Colab. I can import TensorFlow as TF and I can check the version of the TensorFlow that I have with TF dot underscore underscore version. That will give me the version of the TensorFlow. So I run it with Shift Enter. So I import the TensorFlow. That should be version single. Sorry for that. That should be single. Oh, so this is 2.4.1. That's the TensorFlow version that I have. So let's look at the codes that we have here. We're going to develop some models, and we need these libraries to be imported for us to be able to run develop our models. So these are necessary import. So we can what did I give me? Which is it's better to be in a single line. Let me use this one. Why did I say that? Control now. Control C. Let's see that. Good. So this works. Okay, so these are the necessary imports that we need. We have imported the. Let's quickly explain some of the important ones. The train test split is a function provided by sklan that help us to be able to split our training set into training and validation. And the data set, we use that to get the data set. The layers are what we use to get our layers. The models are what we use to develop the functional model style. And the sequential is what we use to develop the sequential model style, as we'll see. So now we're creating a sequential API. And how do we do that? You pass a list of layers to the sequential constructor. So sequential is a class. This is a class. So you pass a list of layers to that. So you build the model. So the number in each layer corresponds to the number of neurons or unit. So for instance now, so we're building this. This is the layer and we're using this dense that we have imported here, the dense layer, and this is the number of unit, and this takes the input shape. The activation function is sigmoid. That's one. Another one is so you will see that this is a list of layers. So this is a list. The list ends here. So the next one is dense. We have another layer called dense with 128 unit. So this is having an input shape because this is the first layer, because the shape of our image is 28 by 28 by 1, which means it's a grayscale image because we're going to be using the MNIST. So if it is a colored image, RGB image, this is going to be 3. This 28 and 28 are the width and the height of the image. One interesting question is that I've asked is that is it possible to specify like this one will be 28 by 14? Does that really work? You can put your thought in the comment below. Yeah, we respond to that later on. You can try it and see what it gives. So this is the final layer. In the final layer we have 10. That means we have 10 classes. So the number of units here is corresponds to the number of classes in our data set, because the MNIST data set has from 0 to 9 digits. So we're using 10 here to represent each of the classes, each of the digits. And essentially you use the softmax because this is over multiple classes. If it is over 2 classes, you just use the sigmoid. Okay. Now we can now build our sequential using the class sequential and passing a list of layers, since this layers is actually a list. Okay, so this is an more succinct way of doing it. instead of putting all this inside this place, as is you will see it done in some other places. So let's copy that. So copy that here, and then we can run that. So we have that run. So now we can begin to see some things about our model. Begin to see something about our model. So let's say we want to get information about a sequential model built on this. We can use summary to get information about that particular model. As you can see there, that we have developed a model. It has total parameters of 23,146, and we can see the number of training parameters is 23,146, and you can see the layers. The name is sequential. Another thing we could have passed there is name, and I think there's a way to pass a name. A name. I'm not too sure about that, but so this is the model is sequential, and you can see the summary here. You can also check the layers. There are a number of functions that you can call on this. So this shows us some of the functions that you can call on this model. You have the feed, which we will still use for training, the evaluate, which is used for test, evaluate generator depending on the type format of the generators, and you can save it. You can get the weight, you can get the layers. So let's see, you want to see all the layers there. So this gives us the layers there, and let's see this. Okay, so this is just it's an attribute, so it just gives us the layers. So if you want to see the first layer, you put, because this return a list of the layers, so this is the first layer, so that gives us the first layer, and you cannot get more information about that first layer if you choose to. Okay, all right, so that is just that. So let's continue. Another way you can create your model is using the hard. So this is a different model we are creating now. So this is the first model we created using a list. That is, we created a list first, and we use a sequential to be able to build it after we have created a list. Another way we can do that is we can actually use the hard method to add each of our layers to the sequential. So for instance here, you just need to first of all create an empty sequential, just like you create an empty list if you're used to Python. So let's say that. So this is creating another model. This is the second model we're creating now. We'll be creating 3 models in now. This is the second model. So this is the second model. Yeah, so now we're using, so here we could create that. So here, this is our model. This is the sequential model we created, and you can still use the summary on this one. It will just be empty. So this is sequential model, and you use the summary on this, and you will see that, yeah, it's a model, but there's nothing inside. So we're having an error for that. Yeah, there's nothing on it's not yet built, so there's no layer on it at all. So let's now begin to add layer to it, as we have. So we had the first layer. So this is the first layer we're adding. So we had the first layer, and we can run that. Let me see if we can use our summary now that we have added the layer. Sequential model summary. Does it work now? Yeah, it does work now because we have a layer added to it. So we already have a layer in it. So if we use the summary, we should be able to get the summary now. So this works now. So this tells us that in the first layer we have the number of trainable parameters that we have is 20960, and that is a dense layer. Okay, so the input shape, this the the shape that we're having as the input is this 28 by 28 by 1. So this gives us 256 times 1. 28 times 28 times 1 gives us this output shape of 256. Okay, so each of them is connected to this 256 unit. All right, with the bias as well. Okay, so let's continue. So we can go ahead and add more layers. So we're building the layers one at a time. So we can add additional layer. So this is additional layer we're adding to that, and we can still add additional layer to that. So this is the last layer that we're adding. So this is the last layer, and we can run all this. So you can say run after. So this will run all of them, and if you rerun this code here, then we can see that we have had additional layers. Number of parameters has increased because of the layers that we have added, as you can see in here. Okay, let me move this a bit so that we can see it better here. So we can see the layers that are added after the order. Okay, the third way we want to create our layers is through the functional API, and this is the third method, the third model. And how do you use the functional API? We'll see that now. So to use the functional API, you have to declare your input layer using this input the input class. So use the input class to define that. So you need to define your input layer here. So in your input layer, that is where you have you define your number of the dimension of your image. So here 28 by 28 by 1. So now we are having each of our layers. You declare each of the layers. So this is the layer, this is dense 1, but you need to now pass the previous layer as an argument to that layer. So that's the convention of functional API. So this is the first layer. Then you have the second layer too. So here you have not built the graph at all. You are just defining variables. And this is the third. So this third layer is the prediction. Normally in most programs, what you are going to see here is output. You will see this one change to output, and you will see this one to be input. So this is input, this is output. So normally that's what you will see as the convention. Then when you are now building your functional API, remember we have already imported model here. We have imported the model class here from keras.model. So we can use this model to build our functional API. And how do we do that? You just say input is input and output is output. So to follow the normal convention, you use S here, you use S here. So you can now just come in here and put this is your model. So this is your model, and you can just put input equals inputs in here, and you put here to be output equals output, which you will see in most other conventions. So we can run everything from here and run after. So this, sorry about there's an error there because this has shifted to the last line. Let's put it on the same line. Okay, output, that's the problem. Oh, we need to rerun all this after again. Any problem there? Let's see. Model, what's the error it's giving us? Cannot obtain. Yeah, model input equals to input, and output is equals to output. Let's try and debug what is the graph disconnect cannot obtain value for that. Sure. Okay, the problem in here is here, so this is where we have the problem. So this should be input here. This should be input since I changed that, and I think that should work now. So that should be input. That's where the graph is disconnected. Okay, that works. All right. So this is essentially how you build a functional API. Okay. Now the next way to create a model is you can use the object-oriented approach. Okay, so this is our fourth model now. So the object-oriented approach. So this is the fourth model. And how do we do that? You need to subclass. You need to create a subclass. So by subclassing this particular class model, that's why we put it in here. So this our proprietary class model is inheriting from class model. The number of layers in each the numbers in each layer corresponds to the number of neurons. So what you do here when you're subclassing, there's an important method which is a call method. You must have this call method there. This is where your forward propagation takes place. So this call method must be there. So yeah, so you define your constructor. So in your constructor you have this super, which you essentially push some of the parameters to the model, to the base class. Now here you can now define your own proprietary parameters, properties. So here you have the dense 1, which is this, and you have the dense 2, which is defined as this, and you have your predictions, which is defined this way. Then in your call, you're going to take in the input and this as multiple parameters, and you're going to call this self-dense 1, and you pass the input to it because you have already defined your attribute here. And it's more like a little bit like functional 2. Then you call the output of that is sent into your dense 2, then the output of that is sent into your dense 3, and at the end of the day you return that set the predictions of your x. And to now create the class, you just create this class. So let's say that. So you see this also as another way by which you can create your model in Keras. Okay, so this one should be inside there. Should be inside there. Okay, so we create our class model, and let's see whether the summary also works on this one. So we that does not work there. Okay, I don't know why that does not work. I will still check if there's any reason why that didn't work there. But essentially, so this is how we create a model. I guess I'm not too sure. Maybe the reason is because we created a class of it. I'm not too sure why we can use the summary on the class model that we created. Okay, but this is intuitive of how to create a customary model using the class. So the next are the conventions. We just load our data set using the mnist that we imported and the function load data. And this can actually, you can change this to fmnist, you can change this to c4, whatever you put in here if you have already imported them here. So here we've already imported mnist, so we can use mnist, but if it is c4, we must have imported c4 term here and all of that. So here we will now, this is pretty straightforward. So you load our data. It's essential we reshape our data because this is coming as a 2-dimensional, and you reshape it. The first value here is the number of samples in the training. So let's see that. It's good we see that, so that we see we demystify what's going on in the code. So the next thing we're trying to do now, we're trying to load our data. So let's see how the loading of our data works. So we have that, and if we're downloading our data now, so if we want to see the data, the shape that we talk about, so you will see that the shape of our data, it's I think this is so there are 60,000 training examples in our training. There are 60,000 of it, okay, and each of them is 28 by 28 width and height. To demystify further, let's just see a single example of it. So let's just see the okay, this is giving us that first value, which is the 60,000 here. So that's the 60,000. But what I actually wanted to do is for us to just say one of that image. So you use the X string, the 0, so this is just one of them. And if you look at the shape of this one, I hope that works. It does work. The shape of that, you see, this is 28 by 28, okay. So the shape of that single array that we display, it means you have 28 rows and 28 columns to give us that first. So this, what you're seeing here, that it's not easy for us to see it. There are 28 rows and 28 columns. So let's see, we want to see the first row alone, so we use that. You see the first row, so this is the first row, and if you want to get the length of the first row, you will see the length of that first row is just 28. So there are 28 in that first rows, and if you want to get the length of the okay, so that's the length of that first row there. So that's 28. Okay, so we can go on. We've explained this. Then, as it's usual, you need to reshape your train. You need to reshape your train too. So this is our test. We reshape our train. We're reshaping our test to the same format like that of the train. Then you normalize. This normalization. This is pretty standard. You take your training set, you normalize by 255, the same thing as this. Now, so we can quickly run all of this now, so that we have our normalized training set. So this is our normalized training set. Okay, so we have our normalized training set. The next thing is we do one hot encoding the labels to break any undesired ordering bias. Okay, this is up and not down, but in their own case you have a one hot encoding. So try to do some cleanup. So you have the Y train and you have the Y test, which are the labels, by using the label binarizer. Okay, all right. I really don't know why they did this one hot encoding, but it's good for us to look at it. So let's look at, before the one hot encoding, let's see what the Y train is like, so we can get what it's happening there. So this is the Y train. So let's now see, after the one hot encoding, what the Y train look like. So this is the so let's see what the Y train looks like again. Yeah, so you can see the one hot encoding, it really makes sense. So what happened is that what the one hot encoding does is that this 5 is now represented with a vector of 10, sorry, excuse me. So these 5, each of these values are now represented with a vector of size of dimension 10, as you can see here. So if I look at the first one, which is corresponding to 5, that means at position, this is 0, 1, 2, 3, 4, 5. So we have 1 at that position, and at every other position we have 0. Okay, so if you look at the second one, which is 0, so here we're going to have, we'll be having 1 here and a 0 in every other place. Sorry, 1 in the first place, because this is 0, 1, 2, 3, 4, 5. Beg your pardon. So for this 4 now, we'll be having 0, 1, 2, 3, 4. So we have 1 here. No. 4. Yeah, 4. That should be at position 4. Let's see how they did this. This is digit 0, digit 1, digit 2, digit 3, digit 4. Yeah, so that should be at the 5th position. So let's see for the second one. Yeah, that's correct. 0, 1, 2, 3, 4. So at the 5th position. So this is what the one hot encode the label. So that's what it does, and it's pretty standard using the label binarizer, and you will see that we imported that here. This is it. That's what pre-processing, the label binarizer. It's pretty standard. All right, so the next thing for us is now to take a certain percentage of the training data as a validation. And how do you do that? You take the training, you pass it through the train test split, and you tell how much you want for the train size, and the rest will be for validation. So you can see here, so here you can have this, gives us that, and that's pretty standard, that's straightforward. Then the next is we now compile. We train all the models for 50 epochs. This is the 50 epochs is just an hyperparameters that you can decide to, and you evaluate them on the test set. So this is creating a dictionary of all the models and using this as the keys, and the values are the object, which are the model itself that we have already created, so that you can just use the key to call the model. So that's pretty easy, straightforward. So we have this here, and so we create a dictionary of our models now. So we can now train our model. We can compile the model, and we can fit the model by training, and we can evaluate the model on our test set. We can report the result of the model. Then once that one is done, then we can use a dash to demarcate it from the second one that we're going to run. That's pretty standard. In computer vision research, oftentimes you need to train multiple models. So this shows a classical way by which you can have, like here, you can have up to like 10 models all together defined in a dictionary, and you can run them and compile all of them, and just run all of them at the same time. Or you can have the same architecture, the same model, and you can run the same model for like maybe 5 times. So that means what you now do is that you fit the model, and once all of them are done running, then you can now average the result of the model, or you can store this accuracy in a list, As it's done, you store it in a list, then you can average the result of all the models if they are the same model at the end of the training. So that's pretty standard. Let's look at some other things here. And the metrics here is accuracy, so that means you are measuring the accuracy. Essentially, this is training accuracy. You could also put in some other metrics. If you check the documentation for Keras on compile, you will see some other metrics like loss, like depending on what you're doing. The optimizer is Adam optimizer. There are other optimizer you could use. You could use RMS prop, you could use SGD, and so on. You could use ADA delta. The loss is categorical cross entropy. Yes, you're using categorical cross entropy here because it's a multi-class classification. If we just have two classes, we just use binary cross entropy. Okay, so what other things? So these are validation. These are batch size, meaning that at every iteration you're going to have 256 processed, and you will span 256 throughout the entire training set. And once you are able to go through the entire training set in complete, that forms one batch. Okay, verbose means whether you want to display uh, the result as it's processing or not, and that's essentially that. So we can just run this, and next time we will see the result, because the 50 epochs could take some time. So we can just run it now, and in the end of line, let's see what's the problem there. So this model.fit, this okay, there could be a problem, so move this up here, and I think that should do it. Okay, so our model is running now to tell us the one that it is running for. That's the one we built with sequential, and the next time we'll continue with how we can load images, and we can see how images actually look like. We have already seen one here when we use the X-train up here, and I decided to show us the images, so we'll be able to see the other ones as we continue in the next one. Thank you very much for listening. I believe you must have learned something. Please leave a comment and let us know how you have understood, and if you have questions, please do let me know. Thank you very much, and see you in the next one.